Hello everyone, this is Hacker on Call. Today we're going to go through Introduction to SIEM on TryHackMe, which is just an introduction to what SIEM is. We'll go through introduction, what is the network visibility through it, the logs, why we should use it, and analysis logs, a bit of actually lab work, and a conclusion. So let's dive in. So, what is a SIEM? SIEM stands for Secure Information Event Management System. It's a tool that collects data from various endpoints/network devices across the network, stores them at a centralized place, and performs correlation on them. The room will cover the basic concepts of required to understand SIEM and how it works. Learning objective, we'll go through what SIEM is and how it works, why is SIEM needed, what is network visibility, what is log sources, and how is log ingestion done. What are the capabilities of SIEM provides? What SIEM for security, security information, and uh, information and event management system. It's something I myself forgot. I just read from the top. So let's go. Network visibility through SIEM. Before explaining the importance of SIEM, let's first understand why it's critical to have better visibility of all the activities within the network. The image below shows an example of simple network that comprises multiple Linux/Windows-based endpoints, one data server, and one website. Each component communicates with each other to access the internet through the router. So we have a diagram here. So we have a server. So we have 20 Linux workstations, like an IT job actually now. 50 Windows, like different classrooms or whatever. You have stations, offices. You have only one router though. You have web server and a data server, sure. Interesting that there are no switches actually between those computers, but whatever. As we know, each network composes that we have one or more log sources generating different logs. One example can be setting up sysmon along with Windows event logs to have a better visibility of Windows endpoints. We can divide our network log source into two logical parts. Host-centric log sources. These are log sources to capture events that occurred within or related to the host. Some log sources that generate host-centric events are Windows event logs, sysmon, OS query, etc. Some examples of host-centric logs are a user accessing a file, a user attempting to authenticate, a process execution activity, a process adding/editing/deleting registry keys or values, or PowerShell execution. So, network-centric log sources. Network-related logs are generated when the host communicates with each other to access the internet or to visit the website. Some network-based protocols such as SSH, VPN, HTTP or HTTPS, FTP, or File Transfer Protocol. Examples of such events are SSH, which was secure shell. Yep, secure shell connection, or a file being transferred via file transfer protocol, web traffic, a user accessing a company's sources through virtual private network file sharing activity. Importance of a SIEM. Now that we have covered various types of logs, it's time to understand the importance of SIEM. All these devices generate hundreds or even, I would even say thousands sometimes per second, depending how many devices you have. Example of IM logs of each device by one in case of an incident can take tedious tasks. That one advantage of having a SIEM solution in place is not only take logs from various data sources real time, but also provide the ability to correlate between events, such as through the logs, investigation incidents, and respond promptly. Some key features provided by SIEMs are real-time log ingestion, learning against abnormal activities. Sadly, SIEMs do not have like an IDS, like a response, incident detection or incident response. No, actually it can only do incident detection, my mistake. No incident response, so still very good. 24/7 monitoring and visibility. This is good, but you also need support, like an IT team to like see the health of the current VM or something running this centralized system. Protection against the latest threats through early detection, data insights and visualization, ability to investigate past incidents. Personally, from my opinion of how work with SIEM, like one of them, it's Rudder, an open source one. Uh, it's not so hard to install it and configure it, but the hardest problem comes in is to set up your own rules for alerts or like spend some real time understanding how to use the dashboards and other abilities there. So actually, it's there's like one of them, right? It's an open source, very good platform. So we have also a diagram on the right, which first we collect the data from the sources, aggregate the data, discover and detect threads, and identify breaches and investigate alerts. Actually, with a SIEM, I personally know, Rudder does have capabilities of detection, like incident detection, but that one with investigate alerts mainly is done by a human. Is registry related activity host-centric or network-centric? Registry. I think it's host, right? Like a registry. I don't think it's network-centric. Yeah. Is VPN related activity to of course it's a network-centric. It's a virtual private network. You have to connect to it. Network-centric. Okay, let's move to log sources and log ingestion. So, perfect. Every device in the network generates some kind of log whenever an activity is performed on it, like a user visiting a website, connecting to SSH, logging into a workstation, etc. Some common devices that are found in a network environment are discussed below. So, Windows machine. Windows records event, every event that can be viewed through the event viewer utility. It assigns a unique ID to each. I already actually went on my previous videos about how this one works. It assigns a unique ID to each of the log activities, making it easy to analyze and examine and keep track of. To view events in a Windows environment, type Event Viewer in the search bar, and it takes you to the tool where different logs are stored can be viewed as shown below. These logs from all Windows endpoints are forwarded to the SIEM solution for monitoring and better visibility. Actually, yeah, they provide much better dashboards and other stuff. So yeah, that's the event viewer on Windows. We already went that on one of the previous videos. Linux workstations. Linux operating system stores all the related logs such as events, errors, warnings, etc., which are then ingested into SIEM for continuous monitoring. Some of the common locations where Linux stores logs are /var/log/httpd daemon contains the HTTP request, response, and error logs. /var/log/cron events related to cron tabs stored at this location /var/ oh you guys can read it, right? Different locations where Linux can say the logs. Here's some example of cron logs. Okay, yeah, the daemon again. So it started, no timestamp found. Oh, so basic logs. Web server. It's important to keep eye on all the request responses coming out of the web server for potential web attack attempts. In Linux, common locations to write all Apache related logs are /var/log/apache or var/log http daemon or d. Here example of an Apache log. So we get a GET request using HTTP 1.0 and it was successful. I think this is port. I think that's port. I'm not sure though. Not sure. Or actually, I don't think that's port. That might be the amount of data. Okay, and then another GET request. Yeah, so those basically. So log ingestion. All those logs provided a wealth of information that can help you identify security issues. Each SIEM solution has its own way of ingesting logs. Some common methods used by the SIEM solutions are explained below. Agent/forwarder. These SIEM solutions provide a lightweight tool called an agent forwarded by Splunk that gets installed on endpoints. It is configured to capture all the important logs and send them back to the SIEM. Actually, that's a very, very common solution. You basically have one VM or like let's say one, yeah, like one VM. When I mean VM, it can be a computer or a system dedicated specifically for the SIEM. Okay, so a VM is running, right? The SIEM itself, let's say, example, a rudder, right? Or some other SIEM. And if you want to actually connect other devices that send logs to forward logs to the SIEM, you have to first install the agent and connect to the SIEM before you can send logs. But after that, it's autonomous. Syslog. Syslog is a widely used protocol that's also very popular, yeah. Collect data from various systems and web service database in real time. Okay, we know that. Manual upload. Some SIEM solutions like Splunk, Elastic Stack, right? Yeah, well, Elastic Stack means Elasticsearch, Logstash, and Kibana. That's abbreviation of Elastic Stack. To ingest offline data, quick analysis. Once the data is ingested, it's normalized to made available for analysis. Port forwarding. Actually, I've never. Let's see what it is. SIEM solutions can be also configured to listen on a certain port, and then the endpoint forwards the data to the SIEM instance for listening port. I'm not sure how secure this actually is. The port will be always open. You really have to configure the firewall to be able to secure that. An example of how Splunk provides various methods of log ingestion from below, or get the data in the following methods. So upload files from your computer, monitoring, and forward it. Sure. In which location within the Linux environment HTTP log start? I think it's slash bars. Shit. Okay, guys, it will be HTTPD at the end. It will be like var somewhere. Var log. Okay, my mistake. Var log. Yeah, I forgot the second that is log. Okay, why scene? So, SIEM is used to provide correlation, collecting data, and detect threats. One threat is detected or a certain threshold is crossed, the alert is raised. That is configurable, and that's actually, like I mentioned, it's you really gotta spend time configuring all those rules because the better you configure, like all those SIEMs are so broad and so good, but if it's not configured well for your specific system, it's useless. It's literally useless. So yeah, you gotta really spend time working on that. The other enables to analysis takes suitable actions based on an investigation. SIEM plays an important role in cybersecurity domain and it helps to detect and protect against the latest threats in a timely manner. It provides good visibility of what's happening within the network infrastructure. SIEM capabilities. SIEM is a major component of Security Operations Center, the SOC ecosystem. Illustrated below, SIEM starts by collecting logs and examining if an event slash flow has smashed the condition, sets the rule, crosses a certain threshold. Actually, I work like as an IT, right? And I take parts of like cybersecurity, right? Like SIEM or some other tools, but I actually would like really to see how SIEM is used in a full dedicated like SOC analyst workflow, because how regularly does the person check manually, even if there is no alerts, for example, right? I personally never saw that happening in my life. Some of the common capabilities of SIEMs are correlation between events from different log sources, provide available visibility to both host-centric and network-centric activities. That's a very good tool. It's not a tool, it's a very good feature. Allow analysts to investigate the latest threats and timely responses, hunt for threats that are not detected. There we go, by the rules in place. I'm really curious how regularly the SOC analysts do specifically this. So what is ticketing, log collection, knowledge base, research and development, aggregation and correlation, threat intelligence, the SIEM, and reporting. Perfect. SOC analyst responsibility. SOC analysts use the SIEM solution. There we go. In order to have a better visibility of what's happening within the network, some of their responsibilities include monitoring investigation, identifying false positives. They're always uh, tuning rules. There we go, which are caused by noise or false positive reporting and compliance, identifying blind spots in the network visibility to cover them. Read the task above. Who did that? Okay, task 5. SIEM tool gets all the security related logs ingested through agents, port forwarding, and essentially we just covered them like 2 tasks ago. Once the log is ingested, SIEM looks for unwanted behavior or suspicious pattern within the log with to help the condition set in the rules by the analysis. If the condition is met, the rule gets triggered and the incident is investigated. Dashboards are the most important components of any SIEM. SIEM presents data for analysis after being normalized and ingested. The summary of this analysis is possessed in the form of actionable insights with the help of multiple dashboards. Each SIEM solution comes with some default dashboard and provides an option for custom dashboard creation. Some of the information that can be found in dashboards are alert highlights, system notification, health alert, list failed login attempt, event ingestion count, rules triggered, subdomains visited. I'm just realizing rather. Yeah. No worry. I just thought of myself. An example of default dashboard in Crawler SIEM is shown below. So application, or yeah, a couple dashboards. Like I said, gotta real invest time into understanding how those dashboards work and what do they represent. Because you don't, that's just gibberish for you almost, or like a foreign language. Correlation rules. Correlation rules play an important role in timely detection and threats, allowing analysis to take action on time. Correlation rules are pretty much logical expressions to set the triggered. For example, the correlation rules are: if a user gets 5 failed login attempts in 10 seconds, raise alert for multiple failed login attempts. Actually, I would even personally raise not alert for that. I would specify a possible brute force, because are you kidding me? 5 failed login attempts in 10 seconds. You either gotta spam one key or, yeah, brute force. If a login is successful after multiple failed login attempts, raise an alert for successful login after multiple login attempts. A rule is set to alert every user's plugin a USB useful if USB is restricted to per company's policy. Yep. If outbound traffic is more than 25 megabytes, raise an alert for potential data exfiltration attempt. Usually, it depends on the company's policies. I really want to see that at work, guys. Never, I've yet to work in a company where, like, I didn't really work in an industry company yet. So I really want to see how this one is forced, like enforced on people. That's not that much of information. Like, it can be a lot of information in text form, right? But it can be response down like a like a photo, right? And then boom, 25 megabytes, or not photo really, a video or something, right? How a correlation rule is created. To explain how a rule is consider the following event log use case. Case 1. The adversaries tend to remove the logs during the post-exfiltration phase of and remove their tracks. A unique event ID 104 is logged every time a user tries to remove or clear event logs. To create a rule based on that activity, you can set conditions for this rule. If the log source is win event log and event ID is 104, trigger alert, event log cleared. Use case 2. Adversaries use common commands like who am I after the exploitation privilege escalation phase. The following fields will be helpful to include the rule. Log source. Identify the log sources captured the event logs. Event ID, which event ID is access of the process execution activity. In case of ID 4688 will be helpful. New process name, which process name will be helpful to include in the rule. A log source is event, okay, and event code. That one. New process name contains who am I. There we go. Yeah, who am I command executed detected. Yeah, that's a very good actually rule. A lot of hackers use who am I every time they log into something. In the previous task, the importance of field value pairs was discussed. Correlation rules keep an eye on the values certain fields to get triggered. They're the reason why it's not important to have normalized logs in there. Okay, alert investigation. Alert investigation. When monitoring SIEM, analysts spend most of their time on the dashboard. There we go. Spend time learning now, as it displays various key details about the network in a very summarized way. Once the alert is triggered, the event/flow associated with the alert are examined, and the rule is checked to see which conditions are met. Based on the investigation, the analysis determines if it's true or false positives. Some of the actions are performed after the messages are. Alert is false alarm. It may require tuning the rule to avoid similar false positives from occurring again. Alert is true positive, performing further investigation. Contact the asset owner to acquire about the activity. Suspicious activity is confirmed. Isolate the infected host. Block the suspicious IP. Let's move to the next task and explore how SIEM works. Perfect. Which event ID is generated when an event log are removed? Is it for something? We just went over that. I forgot that. 104. What type of alert may require tuning up? False positive. False alarm? Well, why isn't false positive? Makes more sense to me at least. So lab work. Okay guys, let's go. Click on the view button. You'll display on the right side of the screen. In the static lab attach a sample dashboard with event will display some suspicious activity happening, alert triggered, which means some events match the condition of some true rule already confirmed. Complete the lab and answer the following questions. Click the start the suspicious activity. Which process caused the alert? Okay, so let's see. Process name. Did the visualization show a list of recent processes? Yeah. The question comes in, what specifically triggered, right? Start suspicious activity. Oh. There we go. We see something. Potential crypto miner activity observed. Find and click on the trigger event to show details. Okay, we already have it. It's a kudo miner executable. Find the event that caused the alert. Which user was responsible for the process execution? Sure. Okay, let's move this one a bit sideways so we can have scroll up right for the okay, so kudo miner, we need the kudo miner. There we go, kudo miner, right? Username chris.fort. Okay, and what is the host name of the suspected user? Host name, this one, hr underscore 02. Perfect. Examine the rule and the suspicious process. Which term matches the rule? Wait, examine the rule and the suspicious process. Which term match the rules cost alert? So it has, okay, security, we have to follow this one. Event view log, security 2, change SIEM. Great work. Now click below rule that triggered it. Alert, potential crypto miner activity if event. Examine the rule and suspicious process. Which term match the rule that caused the alert? So, uh, is it like minor? Yeah. It's, you see what did it? It's if event that was true because it was clearing the history, or what is the clearing the log, and log source, it was that one because it was on the, and the process name equals miner or crypt. In our case it was kudo miner, so I just put it that one. What term matched? Yeah, what term? That term, sure. uh what is the best option that represents the event? Choose from the following: false positive, true positive. You know what, go to analysis action. How would you like to action this rule? It's a true positive because no, wait, tell me. True positive. Because, I'm sorry, who the hell names the program like that and then triggers it, right? Okay, perfect, guys. I think that might be it, guys. We just literally saw how SIEM is used. Yeah, and some other challenges. Okay, guys, basically we completed the room. Uh, Thank you for watching, and see you in another video.